Hi, I'm going to demonstrate how to do a normal distribution problem. The problem deals with body temperatures. It's based on sample results. Assume that the human body temperatures are normally distributed with a mean of 98.2 and a standard deviation of 0.62. Bellevue Hospital in New York City uses 99.6 as the lowest temperature to be a fever. What percent of normal and healthy persons would be considered to have a fever? Okay, so I want to plot my mean, which is 98.2 on my density curve, and then the value that I'm interested in, which is 99.6. And then we're interested in the area above 99.6, because that would be the people that would be considered to have a fever. So I could go ahead and shade in that area if I want. That's the area that I'm interested in finding. Okay, so the first thing I want to do is calculate a z-score. So I take the value that I'm interested in, which is 99.6. And I subtract the mean of 98.2. And then I divide by the standard deviation of 0.62. Okay, so that gives me a value of 2.26. So that means that 99.6 was 2.2 standard deviations above the mean, or 2.26 standard deviations. And I want to come over to my normal table and look that value up. And so I want to go to 2.2 right here, and then 2.26, so the sixth column right here. Okay, so that gives me a value of 0.9881, and that's going to be the area to the left. So 2.206. Then I want to go back to my example, and I know that's the area to the left, and so that's this area right here. That's going to be 0.9881. Okay, so to get the area to the right, I just need to subtract from 1, and that's going to be my answer. So 1 minus 0.9881, that's equal to 0.0119, and that's my answer, or 1.19%. Okay, now if you're going to use the calculator to do this problem, you want to go to the normal CDF function. And to get there, you go to second, and then VARS. And then you put in the lower bound. In this case, our lower bound is 99.6. Upper bound is a very large number. In theory, it goes to infinity, so just a bunch of 9s will do as the upper bound. Then the mean, and then the standard deviation, and then you hit enter. And you get a number very similar to 0.0119. Okay, so we're going to do the second problem. In the second problem, physicians want to select a minimum temperature requiring further medical tests. What should the temperature be if we want only 5% of healthy people to exceed it? Okay, so what I want to do is I want to go back to my normal curve. I have the mean at 98.2, and now I'm given the area to the right as 0.05, and I'm looking for the value of x that corresponds to that. Okay, so the difference between this type of problem and the first problem is that I'm given the area under the curve, I'm looking for x. In the first problem, I was given x and looking for the area under the curve. So I want to go about this in a different way. I'm going to use the table to look up my z-score that corresponds to the top 5%. But I know the table gives me only the area to the left. And so the area to the left here would be 1 minus 0.05 or 0.95. And I want to go back to my table and look that up. Okay, so I'm going to look this up backwards now. All the areas are in the body of the table. That's where I want to look for 0.95. Oops. And then I want to get that corresponding z-score. So I want to find 0.95 or whatever's closest. And so right here I see 0.9495. Now I can use this value as well since that's just as close, but I'm going to use 0.9495. That corresponds to a z-score of 1.64. Okay, so that's my z-score. I'm going to go back to the problem here. I'm going to go ahead and write that down. Okay, and now I can rearrange the z-score formula to solve for my unknown, which is now x. So just rearranging that formula gives me this equation right here. And so my z is 1.64 times 0.62 for my standard deviation plus 98.2 for my mean. Okay, so that gives me a value of 99.217, and that's going to be degrees Fahrenheit. And then that's my answer. Okay, so that's the value that corresponds to the top 5% or the bottom 95th percent. And that's opposite of what we did in the problem above, where the problem above I gave you x and we looked for the area. Here I gave you the area and we're looking for x. So if you're going to use your calculator to do this problem, you're going to use the inverse norm. The inverse norm, you want to put in the area to the left. So you're going to put in 0.95 and then the mean and then the standard deviation, and you get something very close to 99.217.